We are going to be talking about a particular concept that is generally used in many fields of science, and it is called spectrophotometry. Um, Spectrophotometry is basically a technique of measuring the amount of light that a particular substance can absorb and of course also reflect. So the amount of light that the substance can absorb is dependent on a number of factors such as the concentration of the substance. So basically the technique of passing light through a substance such that the substance to measure the amount of light it can absorb, or which is called the absorptivity property of that material, is called spectrophotometry. All right. So now a spectrophotometer is the instrument that is used to measure the amount of light that a substance can absorb and of course transmit. So basically a spectrophotometer actually is used to study measure the effect of a substance on a beam of light. So if a beam of light incidents on a substance, the effect of that substance on that beam of light that is depending on how much light is absorbed or how much light it reflects is what a spectrophotometer measures. All right, and based on the reflectivity and absorptivity of the material, substances in the universe are split into three basically. We have the transparent substances. We have the translucent substances. And the opaque substances. Now, the transparent substances are substances that will allow all the spectrum of light to pass through them without absorbing any. So they are said to be transparent, while a translucent substance is a substance that when a beam of light strikes it, it absorbs some and of course reflects some. So most substances in the universe are actually translucent. And we also have the opaque substances. Opaque substances are the substances that will not allow a beam of light to pass through them at all, but will reflect everything of the surface. All right, and many substances on Earth are also opaque. Now, on this basis is where we actually talk about colors. Now, the color that you see of a material is actually dependent on the effect of that material on the beam of light that strikes it. So you know that light travels in packets called photons, and the path that it takes is called a ray. So this is a ray of light, and of course we cannot actually separate a ray of light. What we actually see with our naked eye is the beam of light. So if a beam of light is incident on a particular substance, the beam of light actually, in the spectrum of light, we have what is called the Roy beam. We're still going to talk about this in detail as we get into the video. Now, the spectrum of light the color that a substance show depend on the spectrum of light that is absorbed and this one that it reflects. So, for example, this substance is appearing. Okay, for example, this marker, you can see a blue tint here. Or look at this material. So this material, for example, appears red because all of the white light that is hitting it, that is striking it, it is absorbing all the spectrum of light, the orange, the yellow, the green, the blue, the indigo, and the violet, but it is only reflecting the red. So because it is reflecting the red, then it appears as red. So this color also appears green because it is only reflecting the green color of the spectrum of light that hits it. Now, and why is the substance white? It is white because it does not absorb any of the spectrum of light that hits it. It reflects everything. So as white light is hitting it, it is reflecting off all the spectrum of this light. Now, how about the black substance? Now, this the black is not a color because what happens is that a substance appears black if it absorbs all the spectrum of light without reflecting any one. So since it absorbs all the spectrum of light without reflecting any one, we say it is black. So I mean the color really appears black. All right. So now let us get into the way the structure of the fundamental principle of a spectrophotometer and how it works. All right. In a spectrophotometer, basically there are two parts. We have the source and the detector. Now, the source simply means the light source. So where the light is going to come from. So this is going to reflect light. And of course, since we know that light travels in a straight line, now it is in that instrument, the spectrophotometer, this is basically what happens. So this is the principle. Now, so light is going to come off of this source, a white light source, and is going to hit what is called, in our physics, this is a lens. Now, the white light that is hitting this lens is going to, the purpose of this lens here, the purpose of the lens is to basically focus the light on another material in front. It's going to bring this straight beam of light, because light travels on a straight line, which is the rectilinear propagation of light, the property of light that you already know. So the light is this lens is also called a collimator. A collimator, because that's what it basically does. It focuses the ray of light that is incident on it, and it is a convex lens, a convex or a converging lens, a converging lens. So and based on this name, you see it converges the ray of light that hits it converges it. So, and what does it converge it on? It converges it on a glass prism. Actually, it converges it on a glass prism. So you basically have something like this. Now I'm just going to, because it's a prism, so basically you have something like this. Alright, so what you have is that it focuses it on this glass prism. Now you remember in our physics that if the ray of light focuses on a prism, a ray of light incidents on a prism, what a prism does, the prism has the capacity to do what? To split that white light into the different wavelengths, which is called the spectrum of light. So at different, so what we call color is actually light at different wavelengths. So it's going to split it into the components of light, which is the Roy wave. So, and this order is actually with respect to their wavelength and of course their speed. So in this order, as you go down like this, you have the increasing okay, in this order the speed is increasing, which means it has a higher frequency but a low wavelength. So you know that wavelength and frequency are actually inversely related. So the higher the frequency, the lower the wavelength. So, and the higher the wavelength, the lower the frequency. So as you go like this, the spectrum of light increases in wavelength and decreases in frequency, and then increases in, and vice versa. I hope you understand that. All right. Basically, so it's going to, the prism has the capacity. It's basically a prism, and it's called a monochromator. Monochromator. So what the monochromator does is, now you also hear people call it the diffraction grating. So the diffraction grating also works like a prism and it's rotatable. So what it does is it's going to reflect the different wavelengths of light. Now it is made to be rotatable so that when so that it can be rotated to select a particular wavelength of light. So all of these colors that we wrote here, we said they are basically what we call colors, are basically wavelengths of light. So it's going to be rotated so that only a particular wavelength of light can pass through pass through a particular component that is called the exit slit. So this will be called the exit slit. The exit slit. So both components act as a wavelength selector. A wavelength selector. So what basically happens is that, so a particular wavelength is now allowed to pass through this slit. Every other wavelength is reflected off of these slits, but only a particular wavelength. So by rotation, only a particular wavelength is able to pass through this slit. Now, at the particular wavelength you have set it, you have rotated it to, is going to pass through this slit, and then you have what is called your sample. So it is now going to get to your sample here, that is kept in this container here. Now this container here is where you pour in your sample. So your sample is basically here. So this is your sample, and this container is called the cuvette. Now the cuvette is actually could come in different materials. It could come in glass or quartz or plastic. And in this laboratory, we basically use the plastic cuvette. Alright, and it's cheaper, of course. Alright, so and the cuvette is made in such a way that there are two sides to it. There is a smooth side and there is a frosted side. So when you are handling the cuvette, you should hold in the frosted side. We are still going to talk about how to handle the cuvette in further videos on how to use the machine. Alright, so the wave of light is incident or strikes the particular wave of light that has been selected, strikes this cuvette, and the substance in the cuvette being translucent is going to absorb an amount of light, and that property is called absorptivity. That property is called absorptivity. So that is what will be called the absorbance of the material. So, and after absorbing that particular spectrum, the remaining wavelength of light, and a portion of that wavelength of light will be reflected, will leave the cuvette and strike what is called a detector. So the detector we wrote here the other time is here. So this is basically the end point, and a detector now translates this information into a digital information, and record. You can have, say, 1.20. All right, so, and then this becomes the absorbance of this material, because what the detector does is it's going to measure the intensity of light that strikes it. So the intensity of the light that strikes it is actually what is called the transmittance. So basically, transmittance is the opposite of absorbance. So the amount of light absorbed by this material is the absorptivity of the material, or the absorbance of the material, while the amount of light that leaves it is called the transmittance, and that is what will be measured by this material. So basically, and it's measured in percentage. So if 100% of light hits this sample, and it absorbs 80% of the light. So basically, the transmittance here is going to be recording 20%. So transmittance is basically the measure of the amount of light that is reaching the detector. All right, so that is basically the principle of spectrophotometry. Now, what happens is that to now work with these values, what we do is we now set the monochromator at different wavelengths to measure the particular wavelength of light at which this substance can, or this sample can absorb light the most. So we now plot what is called the absorptivity spectrum, or absorption spectrum. So the absorption spectrum is basically a graph depicting the wavelength, the absorptivity, a graph of the absorptivity of a material, or absorbance of material. You can see the absorptivity or absorbance of material against the wavelength of the material. Wavelength measured in nanometers, of course. So now it's going to come in different with different peaks and values like this. So at these peaks, it's showing you that the material is absorbing this particular wavelength of light. So all of these peaks shows you that at this wavelength, the material absorbs the light, this particular wavelength of light, very much, and also here. So the wavelength of light, that is this portion where it's peaked here, are the portions where the light absorbs much of the wavelength, while this portion where there are values here are the portions where the wavelength of the light is not, or at the wavelengths that the light does not absorb, the material does not absorb much. So that is after setting at different different wavelengths of light, setting your monochromator at different wavelengths of light is going to show different gradients like this, such that you can plot a graph like this, and then you're able to measure the absorptivity of material. Alright, and this absorptivity, the whole process that we use to get the absorbance of the material, actually makes it useful for us to be able to calculate the concentration of that sample. So, and you remember I said earlier on that the higher the concentration of this material, of this substance, and in the cuvette, the higher the absorbance of that substance, because of course the higher the concentration, then the more light is going to absorb, and the less the transmittance. So that is why the absorbance is given by a law, by a formula, which is according to the Beer-Lambert's law. The Beer-Lambert's law basically says that the absorbance of a material is directly proportional to the concentration of that material, and of course you have it that this is going to be directly proportional to coefficient of absorptivity. This is what is called coefficient of absorptivity, and BC. So this is the formula, and the transmittance is given by the amount, the intensity of light that is incident over the intensity of light that is transmitted. No, the intensity of light that is transmitted over the intensity of light that is incident. So the relationship between absorbance and transmittance is that absorbance is actually the negative logarithm of T. So you can also substitute this into the equation. Alright, so we have IT, which is the amount of light, the intensity of light that is reaching the detector, and the intensity I0 is the intensity of light that strikes the cuvette. Alright, so that is basically the we are also going to talk about this calculation much later. Alright, thank you very much for watching this video. Please do well to ask questions that you are not clear on about this concept. Thank you.